You know, the universe as we know it, it's playing host to this grand cosmic mystery. It's a story that's completely dominated by an invisible main character, a force that shapes literally everything but has never, ever taken the stage. So today, we're going on a hunt for the universe's greatest cold case, the mystery of dark matter.
Okay, so let's just start with the sheer scale of this mystery. Everything we've ever seen or touched or measured, every single star, every planet, you, me, all of it is part of that tiny 5% sliver we call normal matter. The rest of it, a mind-boggling 95% of the cosmos, is, well, a complete enigma, mostly made up of dark matter and its even weirder cousin, dark energy.
And that 27% chunk that is dark matter, it's not just some empty void. No, it's an active, dominant force. So our job right now is to piece together the clues this invisible character has left scattered all across the cosmos.
All right, our cosmic detective story officially starts here. We're going to build a profile of this invisible protagonist that runs so much of our universe.
Just let that number sink in for a second. 27%. That's more than a quarter of the entire universe. And it's a substance we can't see, can't touch, and have never once directly detected. And that makes it, by a huge, huge margin, the most common type of matter out there.
Okay, so we've got the scale of our suspect down. Let's start building a proper profile. What in the world is dark matter really?
So, the working definition? It's actually pretty simple. And what makes it so tricky is right there in the name. It doesn't interact with light at all. It doesn't shine, it doesn't reflect light, it doesn't even cast a shadow. It's completely invisible to all of our equipment. But, and you got to remember this because it's the critical part, it has mass. And that means it has gravity. That gravitational pull, that's our one and only lead.
And honestly, this is where the investigation gets really interesting. Because even though we can't see the culprit directly, its gravity has left this trail of undeniable clues. You could call them cosmic footprints all over the universe.
So yeah, this brings us to the big one, right? The question every skeptic asks and every scientist has to be able to answer. If this stuff is totally invisible, how on earth are we so sure it even exists? Well, let's look at the evidence. Okay, Exhibit A comes from just watching galaxies spin. Astronomers started noticing that stars on the outer edges of galaxies were moving way too fast. I mean, based on the gravity from all the visible stuff alone, they should just get flung off into space, like kids flying off a merry-go-round that's spinning way too fast. The only way the math works, the only way these galaxies can hold themselves together, is if there's this huge invisible halo of extra mass providing the extra gravitational glue. That's footprint number one.
All right, clue number two comes straight from Einstein. We know that really massive objects literally bend the fabric of space-time itself. So, since dark matter has a ton of mass, it acts like a giant cosmic magnifying glass. When light from a super distant galaxy travels towards us and it passes through a big clump of dark matter, that gravity actually bends the path of the light. We see the light get warped and distorted. By measuring that distortion, we can map out exactly where the invisible stuff has to be. We're literally seeing its gravity at work. Okay, so let's just recap the case file so far. We've got it holding entire galaxies together when they should be flying apart. We've got it bending the light from distant stars. And it's not just that, its signature is all over the afterglow of the Big Bang, what we call the cosmic microwave background. And on top of all that, we see that it built the massive, invisible scaffolding that the rest of the universe's structure is built on. The bottom line is, its gravitational fingerprints are everywhere.
So, with all that evidence on the table, the case is pretty much undeniable. Something is out there. The story now shifts from what to who. It's a global manhunt, or maybe particle hunt is a better way to put it, to finally get a look at this ghost.
And this whole hunt really boils down to two prime suspects. The first idea, and this is the frontrunner, is that dark matter is just a new kind of particle that we haven't discovered yet, something like a WIMP or an axion. It just doesn't play by the rules we're used to. But then there's the other, more radical idea. What if there's no new particle at all? What if our whole understanding of gravity is just wrong, or at least incomplete when you get to these cosmic scales?
And the search for it? It's got to be one of the biggest scientific efforts in human history. I mean,
We have these incredibly sensitive detectors buried miles underground, totally shielded from any cosmic radiation, just waiting, hoping for the tiniest little nudge from a dark matter particle passing through. We have powerful space telescopes dedicated to mapping its gravitational effects with breathtaking precision. And then, at places like the Large Hadron Collider, we're literally smashing particles together as hard as we can, trying to create a dark matter particle from scratch.
But why? Why does this hunt matter so much? Because solving the mystery of dark matter isn't just about ticking a box on a scientific to-do list. Finding the answer could literally rewrite our entire book on reality.
And this really gets to the core of it all. See, this isn't just some cosmic accounting problem, trying to figure out what's filling up space. Finding out what dark matter really is, it could finally show us the fundamental rulebook for how the entire universe actually works.
And so that leaves us right here, with this one last absolutely tantalizing question. So what is it? Is the answer some new particle we haven't found yet? Is it a whole new kind of physics we don't understand? Or is it something so mind-bendingly strange that we haven't even learned how to ask the right questions yet? The hunt for dark matter is, I think, just a beautiful reminder that what we see, that's just a tiny, tiny fraction of what's really out there. And the greatest discoveries, they're still waiting for us, right out there in the dark.